Okay, welcome to the third set of definitions for 1001 Grasshopper Definitions by Michael Wickerson at Wickerson Studios. I am continuing with the params file, and we're going through simple containers. And in this one, we're going to take a look at three containers. We're going to take a look at plane and what that can inspire, or what it inspired me to do, rectangle, and box. And you can use these little tools to skip over and see where the boxes are located and where I use those nodes. But there's no reason thinking you have to learn like the absolute basics of how to bring certain geometries into these boxes. You can create them and use them in other scripts. So hopefully you find these interesting and motivational to want to do your own type of thing. We're going to go in here to shaded, and at least I thought I'm locked into something. Whenever you're locked in a command line, you have to exit by right-clicking on Windows. Otherwise, you won't be able to switch out of whatever view you have. So what I've done here with the plane tools, I thought about what a plane is. And of course, there's tons of planes you can have defaulted to under Vector tab. You can go in and you can invent all these. You can make all these planes, construct them, pull them out of X, Y, Y, Z, Z, Y. You can make your own vectors, create all your own. But basically, that's not the vector. I'm going to show how to use it as a container. Basically, I took a plane and I moved it up, but I moved it up in a range, and I do that quite often. So I moved it up in the Z direction, a range of items, and that step count defaults to 10. Be careful on the step count, because if you're using other dividing things up, you're going to have to always be minusing or plussing 1 to these to keep them consistent with series nodes. But that'll make sense later. And whenever you do a range, don't plug a number right in for speediness. Remember, it is going through a domain, and at times you may have to put a domain in that doesn't go to 0, so you don't divide by it, say. So otherwise you'll have a red or orange node at times, which irritates some people, especially when they see your scripts. And you can always put it in a number slider. This one you can double up, control and copy and paste, and put it at a 0.01, say. Anyway, so we moved those up in a series of planes. And with those planes, I then did a rotation on them. And this is pretty simple. Doing a rotation, we'll jump over to what those rotations do. And I rotated them not only in a range through a domain of 0 to 2.0, I have an ability to do a nice little twist here to make a strange shape on there, and I get these different plane structures with X, Y, Z all lined up. So now you're thinking of using planes in your craft. And then I also did that was actually going to a further tool, which was rotation of that plane. This one I put it through a range domain, and similarly through 0 to 2 pi, and that way I keep everything in a sense dealing with radians. Now this one's interesting because the angle itself is already in radians, I believe, so I could easily put it through, but it may be in degrees. No, you don't want to send it over to degrees, just leave it in radians. I am curious why in this one, why I didn't use a pi, and if I funnel that through a pi node, that's gonna make for a full circle. So that's gonna do an awful lot more to it. And that's probably what the design was that I wanted. But since I forgot to do that pi in there, I'm gonna leave it the way it was, in a sense of angle, because that's what I had, and that made the geometry I wanted. So once again, making a mistake or leaving something out is no reason not to use it. What I sometimes do is I group nodes like this, leave them in yellow or red if they're kind of dangerous or warning or playful. Anyhow, I have that set of range, and even though I intended in my mind to put it into a full pi rotation, I didn't actually do that. Then I do a rotation this way, which actually plays with that full pi. And so this, you have the ability to come all the way around very subtly to keep it like this, and then really crank that plane over. So think of planes, and they're very speedy scripts when you do this, so there's no reason not to think, hey, okay, that'll be my main number slider that activates this geometry. I then took a deconstruct plane, and I took the x-axis from the origin and made a vector. So I have the planes. Well, there's no point looking at those. I have the points of where they are, and I took vectors away from those center points. Hi, Ella. And I have a length that I can change, which changes the length of all of these wonderful little arms that are flying up. And so that's pretty cool to think about that if you construct things by fabrication of wood and steel and things like that. So I grabbed the beginning and ending points of those lines. And in doing so, I moved the geometry up 1, and you'll see this moving from here to here. So when I have those vectors moving from there to there, and I'm able to use as points to make boxes on those. And here's where it gets interesting. So I make boxes across all those. Some are thinner slats of wood than others. None default to really zero because I don't have them so coplanar. And then what I did with these lines is not only did I take these lines and loft them, I thought it would be nice to have a loft system with ribs on it and bring those together into a merge, and you have a pretty cool thing, and not too hard to just take them into a move. So I have control over sliding them this way or that way. I have a box here, a center box, that I'm not using anymore, and I must have just popped up. I've mirrored the object. So now when I merge that, I have two mirrored objects that I can slide this way and that way, and I can also take them in the full rotation as wings. So this is a nice little script that I've played with, and you can see how it changes. So if I start to do this, I can roll that around and unfold those wings from two slats of wood, and then as long as they have fabric, I can extend them out like that. What a wonderful little script. Now what would have happened if I'd plugged that in? I would have had something that looked like this. Totally different full circle kind of infinity symbols on each one. So there's a little change that happens. IL is singing for us, making up songs. So you get the same type of thing here, which, do you prefer that over it? Well, it's those mistakes that happen through it that can make it. And I actually prefer the simplicity of this. So I'm going to leave that. And then this one, I'm going to actually bring it to 0. Oh, not that one to 0. That's scale. I'm going to take my sliding factor and bring it back to here to center. So it's kind of this simple object that doesn't need this move tool. And then I'm going to put in things like this cone instead of the boxes. And now you have something that's pretty interesting. The screens took on these cones and they took on a totally different shape. And that, by moving, you have this ability to play with this, and you still have the rotation on the cones. I'm just going to keep this simple. I'm going to use a center box, which is why it was up top, instead of the other one. Yes, Ella? Well, we have a little singer for us this morning, so I'm not going to complain, because what's the point? So another rotation on some larger, wider planks. So that's just how I chose. And they also start from a kind of scripted showing you what kind of stock you need before you need to take the fabric. And you still have to worry about the details of bringing things together with nuts and bolts and mortar and glues and all that. Let's just keep going. I took a cylinder with a boundary representation, plugged that in, and something's gone wrong on that one. And I see exactly why, because I took that and put it in the wrong data, and that's the center box. I meant to put the cylinder, which you have to put a boundary representation on it. And you get another cool symbol, very similar to what the cylinders did. So you can have a sense of that, and you can still play with the shift of that. You get some pretty cool forms. And symmetry is something that you have to work to get away from. It's very easy to go symmetrical in Grasshopper. It's much more difficult to make things asymmetrical. I learned that from listening to Richard Mattson at the Foundation Year teacher at Kansas City Art Institute, and I really appreciated that. Spheres are nice, subtle little tiny things here, and you have to keep their radius pretty tiny for it to be appreciated, and certainly it doesn't really work. It kind of works in that position, this position. It doesn't really have a relevance to the screen. So that said, you've made some pretty cool geometries thinking of controlling planes, and that's really what you've done, is this has been the plane that you've gone through and made, and then how you could actually control that and play with it. And just going through the script with you allowed me to find some more objects. But understand these and where you can orient things. Thank you, Ella. Okay, go. Quiet down a little bit. I got to do second script. You're awesome. All right, so that took a little bit of time, 8 minutes. Let's fly through the next script, which is pretty interesting as well. Going in the rectangle. Making a rectangle, just go make your rectangle tool. And you can do that in the curve down here, primitive, make a rectangle. Not too hard, but what's nice is it gives you a radius factor on it. So not only can you do the X and Y size, you can also pull a radius in from the end. And in time, you can realize that a rectangle and a circle are the same thing. And you're starting to realize the connection between circles and circular arcs and arcs being completed. I exploded to get the points and the different vertices. So I can get all 4 of... sorry, I'm going to take my ungroup off for now. I can take all these. That's not what I want to do. I want to grab all the points, and I want to grab all the edges. And they're all numbered. So like one of the edges would be this one, this one, this one. I only want those 4 corner edges. And then I want lines that go across them. So I want a collection of these from that rectangle, which is fully parametric. Not only rounding it, but also changing the flattening side of it. And you get some problems when you bring it down if you're trying to actually get a solid surface. Merge those all together, and you realize I can put a surface on it, but this isn't right. There's 2 surfaces here that overlap. And that's not good for going in the fabrication or lofting. You get too much data. So what I did was I used a region union, and that's a wonderful thing to do for things like this. Take that and use region unions. Don't get in too far into the intersections and stuck under all the booleans and lost in that until you know what intersection means mathematically in all these nodes and all these physical nodes, regions where you want to begin, and then you might go into these forms of intersection. And that's enough to start, and now you have one nice, beautiful shape that's very fast. Thing to do on display is go into displays up here and go to profiler, and that'll tell you how long these scripts are. Because I've been smart about this script, I haven't had any indication that this takes milliseconds or even seconds to perform. And if you do scripts really poorly, they'll take forever and they'll crash your program. Okay, the last one, we've got 10 minutes left, 5 minutes left, 4 minutes. This might take a little longer. We're going to go into the box tool and show all the ways to make a box. Well, you can make a box from just making a box 2-point and having control over your points and sliding it. You can make it through a rectangular box, which comes from a rectangle. You can make it from a center box, and you can make it from a domain box. You can actually go far and do bounding boxes as well for boxes, and I'll show you that. So here's the use of those nodes. But that said, I've transformed them, and I wanted to move it in a Z direction. I might move it up or down. I haven't decided to do that yet. I've left it low, but I have the potential for moving it. I find the center of it, a centroid, not the area center, but the volume center with an M3 under the surface tools. M2, M2, 3. And what I do is I decided, well, let's rotate it in 3 different directions. Let's do X, Y, Z axis and plug it in. This is not great practice like this. What you're going to want to do is go over and get your merge tool and understand the order of how you put them in. 1, 2, 3. The reason you do that, because now I know if I move these around, I still know which one's feeding in order. Sometimes that matters for data, sometimes it doesn't. Here it doesn't, but that's good practice to do that. There is a rotation that I'm doing on these, so I can play with that and have fun with that little geometry in whatever way I want. And I put a bounding box on it. This is a bounding box, and see how it takes that crooked bounding box and then puts it in other boxes? Don't let those boxes fool you. They are boxes, but they're actually boxes around geometry. And this one does a union box, so it does everything. And what you do is right-click in here and hit union box, or you leave it off. And then what I did with the union box, not the union box, the per object box, is I said, give me the boundary give me the deconstruct the graph and show me the edges. And I chose these edges. I'm not sure why I chose these edges. I actually prefer these edges, but it doesn't matter. I can choose whatever edges I want. And then I'm finding the area. And actually, I'm finding 3 areas on that, which means let's see what happens with that, even though it would be wiser to do this because I only have 1 bit. And you can see the fancy wire here as I change it. This is a list of lists, this is lists, and this is a single item. So let's leave it to where we had it. And we're taking 3 centroids, which is going to provide too much data. Now, because I'm almost through the script, it's not going to slow it down too much. But I'm basically going to take these as a source. That's where they're all going to line up for each one because they're separate boxes on a circle with horizontal or perpendicular frames. And I'm going to orient that, but I need a reference point of where to grab it from. So that's going to change as I move this and I start to transform those boxes from where on those areas I want them. So you've got a pretty cool ring. And since I've gotten into ARA jewelry, I thought, hey, these might be some cool scripts for that program. Like, sure, that's not going to be comfortable on your finger, but you can make some adjustments to those surfaces and get some really nice box structure rings or frames. And once again, symmetry is easy. This is where it gets a little funky in the morph tools and transform. You've got to be careful with the morph tools because they really do slow down scripts. We've got 6 milliseconds coming here. Go back to this geometry and just take it and on this plane build an arc and then put that geometry on there and bend it to the arc. You can't just do any curve, but you can bend to any arc. And you can see the geometry stretching and distorting, and you're starting to get some objects you maybe never would have made. I have to wrap this up in 30 seconds. So we're going to show this as we bend it across that arc. We get a cool geometry, but you're getting some real funk that happens in here. And I love funk and James Brown. I think you ought to listen to that music. But if you take a look in here, we've got some funny stuff that would be pretty hard to sometimes render and finish. You see some strange stuff that if we took it in the render. I got to wrap it up. Say thanks for listening. We'll go on to another script today. I enjoy making these, so let's just keep going. You see there is some stuff in here that's not making much sense visually, even in the render. If we put it to an EMAP, you'll find out that that might even be worse. I'm going to leave it at that if we've run out of time. Thanks so much for watching. There you go. Cool.